I don't think AI has the problem with an overabundance of data.
Right.
Like it can't have a lack of decision making because there's too much data.
Yeah.
AI has the ability to crunch beyond what the human brain can.
Yeah, we have problems with large amounts of data.
That's right.
And I think in frac, it's especially the lack of data. Like most of what you're getting is just surface level, other than like fiber and a few downhole metrics. But that's always kind of the challenge of like we're trying to make these decisions about something that's downhole.
Yeah.
And we don't have anything telling us what's going on downhole. So you're trying to make these predictions of like off of like like what we're looking at the AI for frac. It's like, well, these guys are trying to make prediction of downhole production off of like treating pressure, off of a surface pressure. That's all. Only reading you get back is this surface pressure.
Yeah.
You might grab some temperatures from water.
I'm actually really
There's not a
glad
lot
you
to
went
see.
there. That's one of the sales pitches for our Sonic system, for IntelliSONIC, trademarked by Cold War Technology. The IntelliSONIC system, the comment is pressure is always an action in relation to something else.
Yeah.
Like you can have something going downhole and stopping, or you can increase your rate and your pressure curves will look remarkably similar with no ability necessarily to identify that. But with Sonic, you can actually hear what's happening downhole.
Yeah.
So as a young Cold War Technology with a newly minted IntelliSONIC system, then we stumbled across stage completions.
Yep.
And the fine gentleman at Stage said, "Can you tell what's happening with our Collets?" So I don't think you were on site, but it was one of the first Sonic jobs and one of the first Stage jobs where 72 or 69 Collets were launched, and we could see the travel of the Collet downhole through acoustic and through pressure wave.
Yeah, seeing the travel spikes is awesome. Like it makes decision making on our end unparalleled, right?
Yeah.
You can determine if something has slowed by the time in between. That gives us a higher reaction time, either by increasing pumps, shutting them down, trying to surge the wellbore. The decision making process is made very, very clear by Cold Bore.
If you have a little bit of sand, like is that something that happens downhole with?
Yeah, of course.
With like dog legs and sand, little sand eddies get stuck.
Yeah, you get dog legs, and then just the change between casing ID and our valve, you might get a little duning. It depends on, the flush previous or the flush prior to collet drop. And how the frac went off from the frac before, right? So there's always challenges. I mean, we're dealing with sand, fluid, and a horizontal leg that has, hills to climb and radiuses to turn.
Yeah, well, they still use what is it, least lowest radius for measuring dog leg severity and prompting the well.
Yeah,
like you're taking a survey every 10 meters, 30 meters, maybe sometimes.
Yeah.
And you can have a huge bend and then straight. And then you take the survey and they average the angle over that whole thing.
Yeah.
You don't actually know what's happening downhole. You can guess.
I know they're taking much more readings than we used to take, right? When I was doing it, for sure. Yeah, like super single length, 13 meter joints. You'd get a survey every 13 meters and then calculate over your course length of 30 to get 30 meters to get a DLS. But yeah, I mean, some of these wellbores are pushing the limits of design as well too, right? Running 16, 18 degree severity.
In the lateral or in the build section?
Yeah, build section, right? So you're looking to get things down through like curve and up and down motion. So yeah.
Love it.
Now have you seen the U-turn wells?
I have, yeah. That's where I nerd out for sure. Yeah. Like it blows my mind that you can just do a U-turn with directional tools and start coming back to the rig, right? Like that's crazy.
Yeah.
Have you actually been on one? Because I've heard about it.
No, I haven't. No, I haven't. But yeah, I saw like through LinkedIn and other platforms there that guys are, running these U-turns, which is super efficient, right?
Yeah. I was talking to, his name is escaping me, but at Vital, they were doing one and he was saying that, I was asking him about like any more challenges in drilling sections of it. And he said It's like it's no harder than the build
Yeah.
when they're doing lateral. So
Yeah.
it's not that like drilling is at a point where it's like it's really not a huge challenge for drilling. I guess it depends on the formation where they're at, but where they're at, it wasn't a big challenge. And then they get to reduce. They get way longer laterals, and they can sometimes eliminate a whole well. They don't have to build now.
I wonder if they're fracking, because it's for our viewers at home, what we're talking about is they go down and then they drill a horizontal section and then they loop back. I wonder if they actually frack into itself, like if that section in between the U-turn is like total effective fracture is 100%.
I didn't go that far to understand with that scenario, the U-turn scenario, where how they're completing those wells. I don't know if that's...
I'm not sure either. Like, how big is the radius? Are they fracking along that field? I'm not sure.
They may be more of a SAG-D operation. I don't know. I didn't go that far. I just read the U-turn. I was blown away.
Be good for geothermal.
Yeah, it would be great. Yeah, 100%. Yeah. The cool thing is with something like that, getting to the depths that we get to these days and performing a U-turn in a wellbore and a lateral, like, of course, AI's got to be involved in that, right? Like, through data collection, AI's got to be telling you what you need to get a certain yield out of your drilling parameters, right? So ROP and weight on bit. And
I could imagine. I wonder if it's more due to the more or the higher adoption of rotary steerable.
Rotary steerable's huge, yeah.
Because that's something like 10 years ago, rotary steerable was a kind of a niche tool, niche application when it started hitting the market. Yeah. Especially with things like acoustic tools, not the telemetry side, but the actual acoustic monitoring of wellbore strength, etc.
And those rotary steerables, they're giving you real-time survey data all the time. Yeah.
That's right.
Yeah. Yeah, I don't know exactly what they measure at, but like you get your tool face quite often through rotary steerable.
Data in hand, we rock the bytes and we'll take a stand. Calculators flashing like a disco